Okay, gentlemen and ladies, have here a piece of pipe, a little pipe spool. Someone asked me about flange inspections and flange criterias. Here we have an 8-inch 150 flange spool set. You notice that 8-inch flanges, 150, and instead of 90s, there's these T's. These are sand T's, sand traps, trap T's, whatever you want to call them. Anyway, what we're looking at is we're looking at the flange face, the gasket sealing surface. And here we're going to talk about damage, how it's caused, the length, the depth, all that things. Let me see if I can get this light, highlight this real well. Color balance and all. That looks about right. Anyway, so we have a flange face gasket sealing surface that's let's call it 1.45 inches wide. So 41/100. So the width across the gasket sealing surface, we're talking about the distance from the outside to the inside of the inside of the outside, and how much damage and what depth and where those spots of damage are scattered about radially along the circumference of the flange face. So we're talking about this distance here. And remember that the gasket sits on the outside, towards the outside edge of that. So when we're looking at this, we're measuring how much damage is there in the gasket sealing surface area, and then how deep it is, where it's at, how far it's separated from the other damage. Now you can see from this it's pretty toast, right? Extensive and extremely deep corrosion, metal wasting, right? We can all agree that this is pretty bad. But you see right here on the outside edges, the gasket is still sealing. This was not leaking when it was taken out of service. So, what percentage of the gasket face or the gasket sealing surface is damaged? And you can see it's all on this inside edge here. So that's the area that starts off exposed. It's, most gaskets don't go the full width. They allow for that dimensional tolerance back and forth. So because of that, you're never gonna, unless you're talking about something other than a spiral wound gasket, most of the time you are not engaging the entire gasket face, the sealing surface, because there's always going to be a mismatch between the two flanges, whether we're talking about a piece of equipment or if we're talking about two pieces of pipe. So you can see here we got scale or product scale. This is bad. And you see the inside's ate up too. This measured over 100 thousandths deep in some of these spots. This is quite extensive. And you can see the inside of the pipe is not in any better shape. Pretty extensive, heat affected zone corrosion, preferential, right there where the weld bead is at the girth seam, circumferential weld. You see right here that just anywhere where that gasket wasn't pinched in between the two flanges, it's eaten around most of the way from right here all the way around to almost the other side. So goodness, that's 80-85% of the gasket sealing surface radially, and then half, and in some cases 100% of the gasket face width. And of course depth, like I said, some of these spots are approaching and or exceeding 100 thousandths or 100 mils. That's a lot of corrosion. And The other flange, let me show you this one. It's in similar condition. The extent, over half the width, and radially, essentially 100%. Ironically enough, neither one of these were leaking when they took it out of service. Anyway, thought you guys might be interested in looking. Appreciate you coming along. I'll see you guys next time.